the end, we have some other options um, to customize and add some cameras. So I have noticed that there is a RealSense 3D camera with infrared available in right now in STF file as well. So what you can do is that there is Jinja file and Jinja template, which is essentially a language, a templating language to create the STF as well. It's multi-purpose language, but you can create a STF files with pre-written or predetermined code as well. So in PX4, there is a Jinja template for our RealSense camera as well. You can just use that template and create with the Jinja language and Jinja plugin. You can just create a STF. You can just Google it how to do it, and then when you get RealSense R200 model, you can then easily just write this code here, which is essentially including the link file or model description of STF file here, and then you can just create a new joint with new name, and the type is actually revolved because it can revolve and not fix somehow. And this is for laser RP Lidar. So RP Lidar is low cost 360-degree Lidar. So these two sensors are mostly needed, but for you, as far as the depth map or 3D map concern, in RTAB for drone, the 3D camera is sufficient, but for obstacle avoidance and smooth movement, it is always recommended to get laser sensor as well. Yeah, well, great. So we have added this here. As you can see that this is RS main template. We have added this same line of code I had just shown. This is STF file created with Jinja template. This is here Jinja, STF Jinja. Here it is how it is look like. You can just run it and you can get this STF already. And in the end, actually, you're good to go. And if we just run launch file, what we have created right now, it is, very easily we can see a lot of stuff here. So these files we can just ignore, or these warnings we can just ignore. Even we can set this verbose option to false to not get too much detailed messaging options. Right now we have our system is not really very good, but great. So yeah, we are ready to take off somehow. And here you can see from our lasers that okay, I need to fix this thing here because I have set this too high somewhere. I don't know where actually I have set this too high. This laser sensor, the laser sensor must be, not too high. So let me just then figure out. This is our Lidar joint. Oh, and it's now it is actually 50 centimeter, which is quite high. I can just say 0 here, which essentially means only 5 centimeter higher. And if I save this and run this again, might be this is not so high, but the main thing is that force of it. Main thing is that you're able to actually, so the pose you can actually always change. You can change the position. You can also change the diameter and geometry in visual, in Tringia and all other stuff too, but it is not really important because we have set the mass and gravity very low for just for a tutorial purpose, if we increase mass in tutorial in the real world, it's going to increase the burden on drone, and then might be not fly. It might not fly very smoothly. So for this purpose, we have actually set mass and inertia and all other options like very low for this. And if we go here and come here again and start off-board launch again, might be this time we get Lidar, RP Lidar sensor a little bit lower, but we have set it 5 centimeter. Now might be it's like too low, but it's just kind of trial and hit, you know. And after that, actually, well, it's a bit lower, you know. Well, it is a little bit inside of, it is a little bit inside of, you know, the body of drone. As we can see from the message that there is no disruption. And if there is, you know, some disruption in the inner body with respect to mass and gravity, then it's not shown here and says that it's not ready to flight already. The system is already built in the this time synchronous. We can just ignore this because the frequency at which message is relayed from the sensor and the with respect to time and time synchronous to the PX4 is not exactly matching. That's why it's sometimes giving you error, but you can change this in the RCS or daemon file of PX4, or you can also change this via ground control system. But it's not a big deal right now. We can see it when we fly drone in real time. So let's just ignore this for time being. Well, great. So right now, the other thing is that we need to see some sensor topic here. As you can see now, we have in last video we had a lot of other parameter with infrared which are not really needed. Like there are 2 different depth and 2 different kind of infrared sensor. So right now we don't need these like thermal and infrared sensor right now for the for this tutorial and for our work use case, let's say like that. But it is enough right now. So great. And here you can see the laser scan. Well, you can always, you know, echo the topic to see that what's going on. Let's now in the next step what we're gonna do is that we are gonna increase this to, I don't know, 5 centimeter, 6, 7 centimeter would be surely enough, or maybe 8 centimeter would be enough. So well, great. So next step would be configuring the move base element and cost map, layers, voxel grids, local planar, DWA planar, and all those other trajectory planning stuff. Okay, well, if we just run RVIZ, and then we come here, we add here actually the camera. Here's how camera look like, and if we had R2 depth find, actually here how the depth sensor look like. If we had, I don't know, laser scan, I don't know how laser scan look like. This is the laser scan here, and if I